Hi, I'm Carl Meadows. I'm Director of Product Management here at AWS. I'm responsible for Amazon OpenSearch Service and oversee the OpenSearch project from AWS. Uh, I'm really happy to have you here today. We're going to talk about the roadmap for OpenSearch project, and Amazon OpenSearch Service. So to set a little context of why we're here, why are we talking about OpenSearch? The amount of data that's estimated to be created in 2022 is 96 zettabytes. And if that sounds like an unfathomable number and hard to wrap your head around, then put this into context, and it probably will just make it worse. If you were to put that data on 1 terabyte drives and stack those 1 terabyte drives on top of each other, they would be taller than 18 million Eiffel Towers. And those are Paris Eiffel Towers, not Las Vegas Eiffel Towers. It's a crazy, unfathomable amount of data that the world is dealing with and that people are dealing with. And as we generate all of that data, it's incredibly useful in order to help us make better decisions, improve our efficiencies, be able to respond faster, to uncover opportunities. But to do that, you actually have to be able to sift through that data, make quick decisions, be able to correlate, be able to analyze, which is incredibly challenging given the economics that we can afford, which is incredibly challenging in this day and age with this explosion of data. So OpenSearch is one of the tools that can help you with this. It's extremely powerful. It provides great technology for your traditional text search cases, be it like natural language, text strings, Boolean queries, being able to finely tune relevance to get effective search results when users are trying to find data. For streaming data, if you have systems that are generating high streams of large volume logs in near real time, and you need to distribute that and provide fast access to that data. And then analysis of those time-based data for visualizations, nestable statistics, time series tools. All of that is possible inside the OpenSearch platform and are very common use cases for both the software and the managed service. So that brings me to what is OpenSearch and how does OpenSearch relate to Amazon OpenSearch Service? Well, OpenSearch is an open source project that AWS sponsors, and we work with a community to deliver OpenSearch. It's the open source search and analytics suite. It was derived from Elasticsearch 7.2 and forked last year. It's a distributed search engine. Like Elasticsearch, it's powered by Apache Lucene under the covers and has an integrated data visualization interface, OpenSearch dashboards that ships with OpenSearch. It also includes a series of functionalities added through tools, plugins, clients. So there's a whole ecosystem of technologies that come together to make OpenSearch. And it includes all of the advanced functionality that AWS have been sponsoring previously as part of OpenDistro for Elasticsearch, or security capabilities, learning, machine learning, alerting, all of those functionalities we rolled into OpenSearch as part of the fork. Whereas Amazon OpenSearch Service is our managed service where we run and provide OpenSearch to AWS customers. And the benefit of Amazon OpenSearch Service, it provides all of the technology of OpenSearch, but in a managed package so that you can focus on using the technology and not managing it. It provides it in a secure fashion and provides additional advanced capabilities that are also available in the open source, like observability tools, and allows you to save money by being efficient as you're running these OpenSearch technologies. And we'll talk about each of these points briefly as we move forward. So what do we mean when we say it's managed? So Amazon OpenSearch Service provides you with dedicated clusters of OpenSearch, but it's a simple single API to deploy a cluster. It's a well-tuned and optimized environment. It controls all of the infrastructure, the patching, the installation, ongoing maintenance. We monitor it 24/7 and do self-healing and repairs on the system. Simple scaling, even full topology changes from a single click. You could go from a single node test environment to a prod environment with hundreds of nodes without downtime. Integrated support for cross-region replication, cross-cluster search, and there's no downtimes for updates or even major version upgrades. And we include storage tiering as part of the offering. All of that in a managed package with a simple API wrapped in with everything you would expect from an AWS managed service. Meanwhile, we also provide security. Security is a big benefit of any managed service. So we have integration directly out of the box with SAML. So if you want to use your enterprise identities to control access to your data inside OpenSearch and OpenSearch dashboards, full support for AWS KMS. There's deep fine-grained access control, so you can write security rules to control who can access down to a document level inside OpenSearch. We provide detailed security auditing. We support patching of security issues in the open source on all versions of the managed service that we run. And today we run 19 versions of Elasticsearch and as well as the additional versions of OpenSearch we've launched in the last year. And all of it is wrapped in a compliant package. So support for compliance frameworks such as HIPAA, FedRAMP, et cetera, from an AWS service you get out of the box when you use Amazon OpenSearch service. It provides a rich set of observability capabilities, which are going to dig into observability in the deck as we go forward. But this allows you to combining logs and traces, to integrate your alerting with tools like CloudWatch, to scale up to support up to 3 petabytes in a single cluster, do real-time alerting. There's machine-powered anomaly detection baked in for observability. And all of this comes with no upsell for extended features or licensing, and bundled in with the OpenSearch dashboards capability. And it's cost conscious, so so you can optimize your time to get the most out of using OpenSearch, not having to figuring out how to run and scale it. So it's got screaming data integrations, support for multiple query languages like OpenSearch DSL itself, as well as the SQL and PPL extensions for OpenSearch. Integrated support for our Ultra Warm, which is a scale out warm tier that allows you at a price per gig of 90% discount off of hot. And fast access to virtually unlimited pre-index storage in our cold storage tier that we support, as well as other benefits that we offer, including the recently launched Graviton instances, which save you up to 40%, which we'll talk about right now. So reduce costs with your custom-built silicon with AWS Graviton. We've seen great results with these since we launched them. Customers are really enjoying improved indexing throughput, latency, query performance, and all this means that you can get better performance out of fewer instances powering your cluster. This coupled with our recent release of GP3 support is helping save customers quite a bit of money. So with the GP3 support, we now support double the storage density on a per node basis. So couple that with Graviton, you can run much denser storage workloads on fewer nodes, all of which results in you being able to reduce your overall spend on your cluster. And I just want to touch on that The Amazon OpenSearch service includes a lot of advanced capabilities out of the box that already exist in the service today, such as our k-nearest neighbor analysis query relevancy plugin that allows you to do relevancy on highly dense vectorized data, our learn to rank model. We add support for custom dictionaries and hot reloads of synonym files for search use cases. We have rich security capability, including fine-grained access control, which I mentioned. We are able to troubleshoot performance and availability issues using our trace analytics capabilities and ultra warm and cold. And all of this includes there's self-healing across the managed service and auto-tune, which allows the cluster to optimize lower level memory settings based off the characteristics of the workload to help you make sure you're getting the most out of your hardware without having to understand how to tune JVM parameters. The platform just does that for you automatically. So let's take a few minutes and talk about observability, because some of the features I'm going to talk about later are in the observability domain. So what is observability? Well, in a lot of today's application environments, microservices and cloud scale have created a problem where there's a huge amount of data being generated by these applications, and being able to find those problems, quickly detect them, and then be able to determine root cause has become very challenging. So observability as a space is attempting to solve that. So allowing you to detect, investigate, and remediate problems more quickly. The keys to doing that are really you need to be able to gather several types of telemetry and correlate them together in order to quickly find those problems. So if you think about your metrics, these are your signals of health from your individual systems that are emitted to your monitoring systems. Your logs, which OpenSearch has traditionally been highly used for being able to do log analysis because of its rich search capabilities and analytical capabilities, carry detailed information about the behavior of those systems. And then traces are end-to-end transaction flows throughout those systems. So they tell you information about how the systems are interacting and where faults may be occurring across the system spans. So if you can bring all three of those pieces of types of telemetry together and correlate them, it allows you to much more quickly identify if there's a problem occurring, identify where the problem's occurring, and then quickly get to root cause so you can remediate it. And why is this a big deal? Well, I mean, this may sound intuitive, but downtime's expensive. And as these systems have gotten more and more complicated, as they've scaled more and more, finding these problems and fixing these problems has been becoming harder. So if you look at Gartner, they estimate that for most customers, an individual outage can cost as much as $42,000, or average is $42,000 an hour, and many customers experience up to 87 hours of downtime a year. So that's a lot of money. And so having good tools and good capabilities to be able to shrink that number and provide the best possible experience to your customers and on your applications is becoming more and more important for customers. So what does the observability solution look like inside AWS and managed AWS service? Well, there's a number of tools. I talked about metrics, I talked about traces, I talked about logs. So bringing this information together is really how you get to observability. So if you start at the lowest level, like how do we collect data? Well, OpenSearch can consume data from almost any source. But for your traces, we work with the Amazon distro for OpenTelemetry, or just raw OpenTelemetry collector. And you can use tools like FluentBit or Beats or other agents to collect your logs. And then you would then ship those up into, say, tools like Amazon Managed Service for Prometheus for your metrics aggregation, or Amazon OpenSearch service for all your log and trace aggregation. And then you can visualize those components and correlate those components with Amazon OpenSearch dashboards, for your trace and log analytics, or Amazon Managed Grafana for your Prometheus metrics and dashboards and alerts. That's really the state of the art for an open source based observability solution inside AWS today. Once you log into Amazon OpenSearch service dashboards, you'll see that you actually have an observability plugin. And in that plugin, we've built a curated experience to make observability use cases easier for folks. So this includes, log monitoring views, event analytics, which provides expanded log analytics capabilities. Distributed tracing is built in the observability plugin, which provides you with that rich experience of how all your services are connecting and how they're interacting with each other. There's an APM view, which is your application analytics view that allows you to correlate your logs, traces, and metrics in a single place, and operational panels for dashboarding across these tools. Our observability tool is also powered by a language that's available in OpenSearch called pipe processing language. And this is a very intuitive language for a lot of your sysdev, SRE, DevOps types folks find very intuitive to be able to iteratively explore and discover data by using PPL, which is a piped-based language. So this allows you to drill further and further into data using pipes, and then you can build visualizations based off of these PPL commands, and then do things like parse that data to really find out what root cause is very quickly. We've also added 2 new features with OpenSearch 1.3 in the observability. Event analytics allow you to be able to see your live tail of your logs, which can be a very useful if you're trying to look at log data as it's coming in real time, as well as be able to quickly say log surround. So if I find a particular event, if I want to see the surrounding logs around that to see other issues, it's a simple click to be able to do that. As well as be able to build visualizations from that log event viewer just by using those same PPL commands. I can then visualize the results and create custom visualizations as I iteratively explore my data. And then I can convert those into operational panels if I want to create dashboards. So I wanted to give that context because there's going to be a number of features as we go forward on the observability side, and we've been adding a lot of features very quickly there. So I wanted to set that context. But now let's jump into more the roadmap. I mean, that was the name of the session. That is probably why you guys showed up. So the good thing about the roadmap is, as I mentioned earlier, Amazon OpenSearch service is a managed service for the OpenSearch project. And the OpenSearch project is all open source. So everything we're doing in OpenSearch is available in GitHub. And that includes our roadmap. So you can see all of the data plane or the engine level features that we're building in OpenSearch are all available for you to see, comment on, follow in GitHub in the link down at the bottom there under OpenSearch projects, project 1. And then those features, as they're developed upstream, become available on Amazon OpenSearch service as we consume and provide those versions on the managed service. The managed service also adds other features, mostly around manageability and and improved availability, better cost economic options. Those items you're not going to see those on the public roadmap for the software itself. But so in addition to what we talked about today, there's other items that are going to come from the managed service, but I'm mainly going to be focused on what's coming from the open source project that the managed service provides. So in that area, there's a number of features we're going to talk about. I'm going to drill into log analytics and observability features. So I have a few slides on those. I'm going to talk about log patterns, Prometheus metric integration, security analytics. We also, OpenSearch is used a lot for more than just observability. It's used for search. So we have a number of features that we're going to be developing around search, which I'll talk about, such as relevancy, workbench, query writing, semantic ranking. We continue to invest in the OpenSearch core durability, reliability features. You'll see many of those on the roadmap. I'm not going to drill in very heavily into those in this session today, but it's a big area of focus for us to make the engine more efficient, more reliable, more available. So it's a better piece of software that people are thrilled to run. Extensibility is an area of focus for the OpenSearch project, and I'll touch on that, what that means. Driving performance at cost and scale. We've got to continually push the bar to make OpenSearch faster, more efficient, more economical to run, because customers, like I said at the very beginning, they're generating more data, and I think their data growth is going a lot faster than their budgets. So it's imperative that we continue to really push hard on making this the most efficient, fastest engine we can, so that customers can afford to run it across the full range of use cases that they would like. And then machine learning. There's a lot in the OpenSearch side going on around machine learning. And we'll touch on those across some of these use cases. So let me start on the observability side. I mentioned there's a lot of features coming in the observability side. One I'm really excited about is log patterns. And you can see the GitHub issue there at the bottom if you're interested in clicking on it and learning more. But when we've got these very large quantities of data, often just like filtering on error codes isn't going to be helpful enough to allow you to really parse down common patterns to identify issues and do analytics. So log patterns is really a machine-driven capability of identifying logs that are similar and being able to auto-aggregate them to make it much easier to sift through the noise in a very intuitive way when you're looking at logs. So we're really excited to be working on this feature. This will include being able to convert these patterns into metrics for being able to do analytics on top of them and visualize them, and help you detect unexpected outliers, and remove, equally to the interesting information in the patterns, filtering out uninteresting information can be also just as equally helpful when we're dealing with logs. So this will be a really nice feature. It's being worked on in the open source now, so feel free to go take a look at that. Another area I mentioned is metrics. So OpenSearch, like I said, we have rich support for traces, we have rich support for logs. People generate metrics all the time in OpenSearch and push metrics into OpenSearch. But users' primary metric stores are likely not to move. If you've invested heavily in Prometheus, or you've invested heavily in CloudWatch, or your favorite metrics platform of choice, it's important from an observability standpoint that we can correlate and get access to that data. We don't necessarily have to ingest all of that data too. So being able to do both ingest metrics cleanly and easily and cost efficiently, but also be able to correlate across data and not copy data into OpenSearch that we don't need, so that you can have integration with external sources like Prometheus or CloudWatch, is going to be hugely powerful to help make the observability interface better and richer, in order to identify, detect, and then correlate problems that we're seeing in the logs and in the traces with what the primary metric stores are actually seeing. And so again, like the traces, this issue is being tracked in the public repos. Feel free to go, take a look at it there. And, we're really excited to see that feature to really help round out the observability tools and to provide that single pane of glass all from OpenSearch. Another area which we haven't touched on is in analyzing security events. So this is a very popular use case in OpenSearch. So OpenSearch already is a super powerful tool for being able to look at logs, being able to aggregate data, being able to find data. But with the security analytics features that we have in development, we're going to help make those use cases easier in OpenSearch by providing support for a rules engine that will enable you to configure rules to parse each document that's coming in for various security, potential security issues. So we're going to add support for the Sigma rules, which is an open source rule set of over 2,000 rules that will you'll automatically be able to parse your logs against. And then extend that with out of the box support for various logs types, so that you can then use those rules to identify security findings, generate alerts, create your own rules, and create your own insights and dashboards on these security events. So this will really help make it easier for SecOps teams to use OpenSearch to build their security analytics experience by providing much better primitives for them to build on top of, as well as out-of-the-box experiences for security analytics. So I'm really excited to see how folks use this and how much heavy lifting it's going to take off folks that are using OpenSearch in these security contexts, because the out-of-the-box experience is going to be so much better. So again, security analytics is being developed in the open. You'll see the GitHub issue there. The first version is currently on the roadmap for OpenSearch 2.4. So you should start seeing some of these features coming very soon. And extensions is another area. So a little background. So OpenSearch and Elasticsearch before it has a plugin architecture. And so plugins are super powerful. You basically are, a plugin is a Java code that runs in the JVM that's powering OpenSearch. So you can do a lot with a plugin. However, there's some problems with plugins. They're very difficult to write, and they're very difficult to maintain. The versions are tightly coupled because they are coupled with the JVM itself. And the interfaces aren't well defined. So writing and maintaining them is challenging. And there's no security isolation. So the plugins, like I said, have access to the full JVM, which can make it where you really have to trust the code that you're running in a plugin because it's got full access to your data. So one of the things we want to do with OpenSearch is build a better mechanism for being able to do that type of extensibility, to give you the power of the plugins, but to make it a much better experience for developers and for consumers of this functionality, so that we can really help grow an ecosystem around OpenSearch of people building extensions on top of OpenSearch. So how we're doing that is with extensions. Extensions solve some of the problems with plugins in that they're not coupled by version. They've got a very clear defined SDK and API for how they integrate with OpenSearch, and they've got secure sandboxing by default. So that way, if I build a plugin or an extension in this case, and say that extension is a Korean analyzer, I can write that extension one time. I'll say I would write it against the OpenSearch 3.x. And I would not have to rev it with every single patch release of OpenSearch. That extension will continue to function. I'll have a defined SDK and API that it's easy for it to interface with, and all of it will be secure code. So if I'm a third party and I see this extension, I can be confident that I can download this extension. I'm not creating a security risk for myself because there's a sandbox that extension's running in, and it doesn't have unfettered access to the host or to my data. Again, the extension's link is there on GitHub, so feel free to take a look at it. I'm really excited about this project. I think it's going to really help a lot more people build their own experiences on top of OpenSearch and make those experiences available to a lot wider audience. And so the last big area I wanted to talk about today is search. So we talk a lot about logs and observability and analytical use cases with OpenSearch, but OpenSearch is hugely popular as a search engine. It backs a huge number of sites are powered by OpenSearch for providing full text search. But building these experiences is more than just a search engine, and it's complicated. It's too complicated today. There's a lot of moving parts that folks have to put together to build search experiences. They need to figure out how they're going to ingest their content from various sources, and they have to build pipelines and analytical tools to measure the quality of those search results. This includes getting your clickstream data, being able to have a testing framework, being able to compare the results of changes over time to ensure that you're getting better relevancy and better correctness in your searches to improve the business outcome of those searches. This includes being able to interpret the intent in user queries and putting all of that in a modern UI. Today folks have to do all of that on top of the search engine. And then there's also challenges with some of the more modern approaches. So OpenSearch is an integrated BM25 as a relevancy algorithm. It's tried and true and used broadly. But there's additional techniques that are available inside OpenSearch, such as learn to rank, which allows you to personalize search results. But again, in order to use that effectively, you've got to have good training data, and the workflows can be very challenging. And then leveraging semantic capabilities with densely vectorized data, that can be challenging because you've got to have good training data with vector embeddings, and then integrating those methods with BM25 and other techniques. All of this requires a lot of expertise. So, the OpenSearch plan is to invest in making search easier and better too. But it's going to be across a number of dimensions. One is making sure that the classic search is easier, that we've got good connectors for sources, that we've got good converters for common formats to make setting up those ingestion pipelines easy, that we've got tools to make it easy to capture your logging of your clickstream data so that you can do your analysis of how your searches are performing, and you can really tune the relevancy and make the tweaks to get great outcomes from your search and your search experiences. This will include as well a relevancy workbench for measuring and tuning the quality of searches, including doing A/B testing, offline testing, interleaving results, a query rewriting tool, and ultimately a UI for making it easier to build search experiences and bundle those search experiences. Many of these projects are already up on GitHub. I didn't put all of the GitHub links in this deck, but you'll see that there, if you go into GitHub and you look at the OpenSearch core repo, you'll see a lot of these projects and issues are in the works. So that's your more classic search set of problems. At the same time, we're going to keep pushing the state of the art and make these modern approaches better and easier to use and more scalable. So this includes improvements around learn to rank, to have a integration with the logging capability and the clickstream so that you can build those personalization loops and those training workflows really easily to get that nice out-of-the-box experience for personalization. And vector and semantic ranking. So building on top of our KNN capabilities today, we're going to extend that. Right now, we've got a standalone KNN plugin that's super powerful that we've built on. There's newer KNN, native KNN integrated into Lucene. We're going to add support for that. But we're going to extend it to include tools around being able to support semantic ranking with pre-trained embeddings, and then tools to be able to tune large-scale models and semantic search results for smaller sets of targeted data so that you can get much higher quality semantic results, combine those with your BM25, combine those with Learn to Rank to really provide customized, great search experiences for your customers. So we're really excited to see a lot of the work in search is starting to come together and help make not just OpenSearch a great analytics platform and observability platform, but keep advancing it as an amazing search platform. So with that, I just want to end on, I hope this was a useful session. All of these features that we're developing in OpenSearch upstream, you can follow them on GitHub. They will be making their way into OpenSearch releases, and those OpenSearch releases then become available on Amazon OpenSearch service, which is, in my humble opinion, one of the best ways to run OpenSearch. No offense to any of our partners out there that also run OpenSearch services. So Amazon OpenSearch service today on AWS, we support tens of thousands of customers, hundreds of thousands of clusters, just a staggering amount of search requests running through Amazon OpenSearch service. And we're committed to constantly raising the bar, making the service better, delivering you better features, delivering you better availability, delivering it at a better price point. I hope you found the session today interesting, and will give the service a try if you're not using it already. With that, thank you.